So the second article of this chapter number 1, center of mass of a system of n particles in 3 dimension. Now see, we have studied about the center of mass for a system of 2 particles in only 1 dimension, and in that class I given you the reason that why should we directly move in 3 dimension. For 3-dimensional study of system of n particles, you have to consider the following figure. So here the figure is provided in which a system of n particles in 3 dimension. Which are the 3 dimensions? This y, z and x, and this O represents the origin. Now we can clearly see from the figure that this is the system of n particles with the mass m1, m2 up to so and so mn. So what it means? The first particle is having mass m1, the second particle is having mass m2, and so the nth particle is having mass mn. Now, if you want to find the distance what we have studied in 1 dimension, but it is slightly different as far as this 3-dimensional study is concerned. So, with respect to origin, the distance or the position of these particles are given by the position vectors. So the first particle is having the position vector r1, the second particle is having the position vector r2, and so the nth particle is having the position vector rn. So with this our description for a figure is over. Now I am directly moving to find out the center of mass from the figure. Where is the center of mass? They have assumed, see, it is not actually center of mass, but they have assumed that let this point should be the center of mass, that means C point, and with respect to origin, its position vector is RCM, where CM is suggests for center of mass, not a simple centimeter. Now, the position vector of center of mass for a system of n particles is given by, it is very similar to that of in 1 dimension. Therefore, here R, we generally denoting the center of mass or any position vector as R, and here the subscription suggests Cm is equals to center of mass. So, as similar to the one-dimensional theory for center of mass, I am directly writing the equation as m1r1. Here r1 is replaced by x1 plus so and so mn rn divided by the total mass m1 plus m2 plus so and so plus mn. But what is the denominator suggest? It is again the total mass of the system. and I am writing this total mass is equals to capital M. And with this, now our equation will be RCM vector is equals to M1 R1 vector plus M2 R2 vector plus so and so Mn Rn vector divided by this capital M. Now, what I am going to do a slight modification, because in examples or any illustration this will be very helpful to you. So, I am replacing this M into the multiplication with this position vector of center of mass. So, M into RCM vector is equals to M1 R1 vector plus M2 R2 vector plus so and so Mn Rn vector, where M is the total mass of the system. So this is the end of your theory center of mass in 3 dimension. But there are some sub-theories of this unit or this particular article which we are going to study in our next class. So here the theory is, it is actually the sub-article of center of mass of a system for n particles. So this is the correlated theory between the motion of center of mass and the Newton's second law of motion. So I am starting this theory by one assumption, that if the mass of each particle does not change with respect to time, so the equation which we have obtained as the last in the above theory, so differentiating that equation, because the mass is constant with respect to time, therefore differentiating that equation, was MRCM vector is equals to M1R1 plus M2R2 plus so and so Mn Rn. So what we will get by differentiating with respect to time? Therefore, capital M is as it is, dRCM vector divided by dt is equals to M1 dR1 vector by dt plus M2 dR2 vector by dt plus so and so Mn dRn vector by dt. But if you remember, the change in position with respect to time is called the velocity, because the change in position means either displacement or distance. But if we divide the displacement by time, then we will get velocity. So, according to this statement, I can write down the value of dRCM by dt as VCM. Similarly, dR1 by dt is equals to V1 and so. You can write down up to drn by dt as Vn. So the equation will become capital M VCM vector is equals to M1 V1 vector plus M2 V2 vector plus so Mn Vn vector. But if you remember the definition of momentum, P is equals to mv. So here, if I am writing the subscript m1v1, so this will be my p1. So I can rearrange this equation as mvcm vector is equals to p1 vector plus p2 vector plus so pn vector. Now this is the momentum of different particles, but if I am adding them, then this will be my total momentum of the system. And this is the total momentum for n number of particles. And you should not forget that the left hand side is as it is. So this is MVCM. So what this equation suggests? So this equation is very important for us. So this equation suggests that the total momentum of system of particles is equal to the product of, see, I am just writing the statement which is expressing this equation. See, the total momentum means capital P is equal to the product of this total mass of the system of the system and the velocity of center of mass of the system. So this is the explanation to the equation which we have studied earlier. Now, we have started our article with the correlation with Newton's second law. So which are the physical quantities appear in the Newton's second law of motion? So the quantities are appearing into the Newton's second law of motion is force, then comes mass of the particle, and then acceleration takes place. But here if you see the left hand side, then here the velocity comes. Now if we proceed further by differentiating this velocity with respect to time, then we can have the value of acceleration. So let's move further by differentiating the equation T is equals to mv cm vector. Therefore, m dvcm by dt is equals to dp1 by dt plus dp2 by dt plus so and so dpn by dt. Therefore, if you look at this equation, the right hand side, the force is equal to the time rate of change of momentum. So this is the time rate of change of momentum. So my right hand side is the force actually according to Newton's second law of motion. But F is equals to dp over dt. So if I put 1 over here, then here the subscript 1 comes. So my modified equation will be look like m dvcm by dt is equals to f1 vector plus f2 vector plus so and so fn vector. So this is the generalized result. But according to Newton's second law of motion, I can also write this equation as m1a1. So my right hand side I can also write as m1a1 vector plus m2a2 vector plus so and so mn an vector. Therefore, m dvcm by dt. So this equation is also very helpful, and here the forces which are appearing F1, F2 and Fn are the different forces acting on the system of n number of particles, and this total force I can also write as capital F because it is the resultant force. This is nothing but the resultant force, and you should also have to written these holes here if it has been asked in the descriptive portion of your examination. Again, one more thing you should remember, that the equation m dvcm by dt is equals to m into acm, which means this acm is the acceleration of center of mass of the system. So you can write in both these cases. Now, here the force which you have considered. So these are the force of how many kind? Because this force is not a single kind of force because it is the resultant. So which kind of forces are acting on the particles or the system of the particles? So let us study in this force type of kind. So mainly there are two kinds of force acting on the particle. So which are the two kinds? The first one is the internal force prevailing among the particles of the system. So this is the force between particles and particles. So I can describe you this kind of force by just putting a figure. So this is the figure by which we will explain the internal forces of the system, and the second kind one is external forces of the system. Here if you see that here is the particle 1, here is the particle 2, and the direction of force is towards the center of mass. This is F12 and this is F21, means force on the particle 2 by particle 1, and here the force on the particle 1 by particle number 2. So, this outer side suggesting us the external kind of force, and here we will also see the effect of external force and internal force by one geometrical representation. So this is the geometrical representation. These are the internal force and these are the external force. But if you see the direction of the internal force means F12 and F21, so both are having the different direction, therefore, and are having the equal magnitudes. So F12 is equal to F21, but the directions are opposite. So here the negative sign comes, and also the direction of internal force is towards the direction of center of mass of the system. And one more important thing, the origin of external force, you see, this is the origin of external force. So center of mass is called the origin of external forces. So let's move further and move to some further description. If you see, according to this particular law, and this is nothing but the Newton's third law of motion, then with the help of this theory, F12 plus F21, which is the resultant internal force, is 0. And now I will write one statement according to this discussion as m dvcm by dt, which I can also write it as m acm is equals to F, because according to Newton's second law of motion, and I can also write this as the dt over dt because the rate of change of momentum with respect to time. So, this equation suggests what? This equation suggests that the resultant external force. Why I have written over only external force? Because the resultant internal force is 0. So this resultant external force acting on a system is equal to the rate of change of total linear momentum. And this is the Newton's second law of motion for a system of particles, which can be asked in 1 marks MCQ or SQ type of question. One more thing which you have noticed over here, that the center of mass of the system. Now I will write the center of mass as COM. So the COM of the system moves under the influence of the resultant external force F as if the whole mass of the system is concentrated, because we have seen the velocity, the acceleration, the force, all these kind of quantities are related to the center of mass. So, they are concentrated at its center of mass. And this is the most important result from which the following statement will be very, very interesting for you, because the Newton's second law of motion can be written without the help of third law. For a single particle, but if we are considering the system of particles, then Newton's second law of motion cannot be written without the help of the Newton's third law of motion. So this is the fact, or we can say the effect of independency. Or interdependence of Newton's law of motion. So this is also important, that explain the interdependence of Newton's laws of motion. So this can be asked in either 2 mark. Now we will solve some illustration related to this particular theory.